Let's take a look at some problems involving the fundamental principle of counting. Now, just to review before we get into it, it's a method for counting the number of outcomes, where the order of outcomes oftentimes matters, and then I'm looking at multiple events with different outcomes for each event. In order to find the total number of outcomes or sample space for the situation, you would multiply those together, and we often use what's called a decision chart. So we're going to look at this example here. We are going to take some alphabet blocks, and we're going to look at how many three-letter arrangements can be made by lining up the blocks. But we're going to say the first one has to be a vowel. So my decision chart is going to have 3 blanks, and the first one is only going to have 5 choices because my vowels are A, E, I, O, and U. So one of those 5 letters would be my first choice. Then I'm left with 25 remaining letters and then 24 for my third letter. I'm going to go ahead and multiply those 3 together, and the fundamental principle of counting tells me that the number of principles or possibilities is 5 times 25 times 4, or 3,000. Now let's apply that to some examples. In this case, the men's department store sells 3 different styles of suit jackets, 6 different shirts, 8 different ties, and 4 different pairs of pants. How many different suit combinations consisting of a jacket, shirt, tie, and pants are possible? So as I make my decision chart, I need a blank for each different option. So I could have one for my suit, jacket, one for my shirt, one for my ties, and one for the pants. Okay, and then I'm just going to go in and fill in the possibilities. There's 3 different choices for a jacket, 6 for a shirt, 8 for a tie, and 4 for pants. And then I would just go ahead and multiply those together to get the result. Again, we'll apply this counting principle to the second problem here. A baseball manager is determining the batting order for a team. The team has 9 players, but the baseball manager wants the pitcher to hit last. How many batting orders are possible? So what I'm going to want to do is go ahead and put out my 9 blanks. But in my last one, I know that I'm only going to have one choice. I'm going to assign my pitcher there first. So once I assign my pitcher to the last spot, then I'm going to go ahead and fill in the rest of it, and I would only have 8 choices for the first position, then 7, 6, 5, etc., all the way down to 1. Once I have that set up, I'm going to go ahead and multiply to get the total number of lineups or batting orders that are possible. And then we'll look at one more here. It says how many 8-digit numbers can be formed if the first digit cannot be 0 and the last digit cannot be 1. So again, I'm going to go ahead and make my decision chart with 8 different blanks and then fill in the number of possibilities for each spot. Since the first digit cannot be 0, my only choices are 1 through 9. So I would have 9 possibilities for the first digit. And then my last digit cannot be 1, but it could be 0. So I would have 0 and then 2 through 9 for my options for the last digit. So I would also have 9 choices there. All of the other numbers would have a 10 because it could be 0 through 9, which is a choice of 10, or gives me 10 digits to choose from. Then I'm going to go ahead and multiply them out to find the total number of 8-digit numbers that can be made using this criteria.